The Big Bang wasn't an explosion in space. It was actually the expansion of space itself. And that single distinction, well, it changes everything we think we know about the beginning of the universe. When most people picture the Big Bang, they imagine matter bursting outward into an empty void. But there was no outside for it to expand into. Space, time, matter, and energy all emerged together. Every region of space began expanding from an extremely hot, dense state, not from a single point, but everywhere at once. We know this from Edwin Hubble's discovery in the 1920s. Distant galaxies are moving away from us, and the farther they are, the faster they recede. This observation revealed that the universe is still expanding, meaning it must have been smaller, denser, and hotter in the past. If we trace that expansion backward, we reach the moment when the known laws of physics break down, the earliest instant we call the Big Bang. So, what actually banged? Not an explosion of matter, but the rapid expansion of space-time itself. At roughly 10 to the minus 36 seconds after the beginning, the universe underwent what we call cosmic inflation, an exponential growth phase that amazingly stretched space even faster than light. This didn't violate relativity because it was space expanding, not objects moving through it. Before inflation, the universe may have been just a quantum field filled with all these tiny fluctuations. As space expanded, these fluctuations were amplified, eventually forming the seeds of all cosmic structures. Every galaxy, star, and planet, wow, really everything, can trace its origin back to these microscopic variations in the early quantum fabric. But what caused inflation, or the initial state itself? We don't yet know. Some models suggest the universe emerged from a quantum fluctuation in the vacuum. Others imagine a cyclic universe, where each Big Bang follows a previous collapse. And in the multiverse scenario, our universe might be just one bubble among countless others. The cosmic microwave background radiation, the faint afterglow of the early universe, is the strongest evidence we have. It's a relic of the moment when the universe cooled enough for light to travel freely, about 380,000 years after the Big Bang. Its tiny variations mapped those original quantum ripples that later grew into galaxies. And the expansion hasn't stopped. Today, it's accelerating, driven by a mysterious force called dark energy. In that sense, the Big Bang never truly ended. The universe is still expanding, still evolving, and still echoing that first moment of creation. So what actually banged in the Big Bang? It wasn't matter or energy exploding into space. It was space itself being born. The universe didn't start somewhere in space. It started as space. This is Infinite Narratives. If the origins of the cosmos fascinate you, subscribe, and let's keep uncovering how everything began. See you soon.